Hello, my name is Jose Blanco, and of course I work with ACRP. This is a meeting with the ACRP Board of Directors, and this is what ACRP is about. It's about bringing people together, about sharing knowledge, expertise, and so on. So what is ACRP? ACRP is the acronym, the short name for the European Association for Construction, Repair, Reinforcement, and Protection. I know it's a very long name, but it's an association that brings together everybody that is related with the maintenance of any kind of structure, building, no matter what it is, no matter which kind of material. Even though I got to say that most of the associations that are members of ACRP, mainly they focus on concrete, but we include everything because some of the associations also do extensive work with the steel and masonry structures. This is the current membership when it comes to associations. You can see here Belgium, Czech Republic, France, Germany, Greece, Norway, Spain. We also have individual members, and an important thing is that from the beginning it was decided to allow institutions to become a direct member, so that's why we already have the Finnish Transport Infrastructure Agency, and we expect more public administrations to get involved. To achieve our mission, which is to promote the maintenance of the constructions, we need to bring together everybody, the companies that do the work, contractors, manufacturers, the engineering companies, the associations, the asset owners, which in most cases will be public administrations, and to exchange between them the best practices, the current regulations, and also ideas and expertise when it comes to training. Mainly, we want to create awareness about the need to maintain what we have built. So we need to develop the knowledge and the expertise to inspect, to project the maintenance, and also to execute that work. And that comes through inspections, through projects, through quality control. We do multiple activities. We have working groups, we have online contents, we have education, and we have also regular meetings. At this point, we have 3 working groups. And I say at this point because probably next year we will have a couple more. Last year, it was the first year that we produced the ACRP special publication. This year, we're going to change the name, and it's going to become a yearbook. We are also doing, as I said before, some webinars. The webinars are done free of charge for anybody. So when they are done live, anybody can participate and watch the webinar and so on. And once they are done, we keep the recording and the conference book, which is available for the members on the website of the association. We are producing some audiovisual materials, and we are also trying to publish the audiovisual materials that have been done by the different national associations. So you can go to our website and you can see some of the contents that are available. Like any other association, we also want to do events, and I say we also want to do events because ACRP was started in 2019. We had a meeting to finally decide to create the association after several meetings among different national associations. Feel free to reach us if you have any question, comment, suggestion. Thank you very much, and we hope you have a good meeting. Thank you.
Good evening, everyone, and welcome to this ACRP webinar about new developments in European regulations on concrete structures. I want to thank everyone for attending and let you know that you can ask your questions on the chat, and I will read them to our speakers later in the roundtable. So with no further ado, I would like to ask Jesus, our first speaker, to turn on his camera. Hello, welcome. Thank you very much.
Thank you, Maria, and thank you to the ACRP invitation to participate in this webinar. Today, in a very short way, we are going to present some of the main changes that will be included in the new version of the Eurocode. It will be impossible to go in all the details, and afterwards, if some of you need more information, my email address will be in the last slide, and the 3 of us, we are ready to collaborate with you and to pass you detailed information. Today, we are going to distribute the presentation between myself, Jose Maria Arrieta, and Eva Oller. Jose Maria and myself, we are chairing the Spanish Mirror Group of Eurocode 2 and representing Spain in the CEN corresponding subcommittee. And Eva is one of our experts working at European level on some areas, in this case of the strengthening of existing structures with FRP and also on the use of embedded FRP reinforcement. So for those who are not familiar with the Eurocodes, the group of Eurocodes are presented here, and they are dealing with everything related to the design of concrete, of the design of structures. Concrete is only one of the possibilities. So in each case, we need to use the corresponding Eurocode. In the case of concrete, the Eurocode number 2, together with the basis of design, the Eurocode 0, the Eurocode 1 on actions, the Eurocode 7 on geotechnical design, and the Eurocode 8 on design structures, combined by the national annexes for the application in each country of the Eurocodes, and also of the European standards on materials and execution of structures. So why we are revising the Eurocodes? Because the Eurocodes exist from the beginning of the 20s, and it is because it is aiming to reduce the number of what it is called, or that they are called national determined parameters, values that can be determined by each individual country, to improve the ease of use, to incorporate the recent results of the relevant to innovation, to incorporate also everything related to the contribution of structural design to sustainability, and to provide background documents. In the specific case of Eurocode 2, now we have a background document of more than 1,000 pages supporting what is now new in the present version of Eurocode. So the Eurocode that we are going to deal today only is the Eurocode number 2 on design of concrete structures. And during this short webinar between Jose Maria Arrieta, Eva Oller, and myself, we try to present some of the main modifications and some of the new contents that were not included in the scope of the present available Eurocode that was approved at the beginning of the 20s. So the webinar only present shortly some of these modifications and new contents. So for the first group is related to those topics that were covered in the previous Eurocode. We have selected these 6 items on durability, on concrete compressive strength, on partial factors for materials, on shear, on punching, and on anchorage length, in order to highlight some of the main modifications that you are going to find when dealing with this new version of the Eurocode number 2, that the technical content is almost close. We have the last meeting at the end of June at the European level, and in principle, the technical content of this Eurocode will be almost close for all the procedures of CEN and the votes over the different countries by the beginning of next year. So the first topic is the durability, and in the case of the durability, we would like to emphasize some of the questions, some of them, of course, related to corrosion of the reinforcement, although they are also covering other type of the deteriorations in the concrete structures. So again, the Eurocode includes the exposure classes in a similar way than the previous versions, with slight modifications on different exposure classes related to chloride attack, carbonation, chlorides, seawater, on free-thaw attack, on chemical attack, and also mechanical attack of concrete by abrasion. The new content of this Eurocode is related to what is called exposure-resistant classes. It's a way to define the quality of the concrete to be selected for the different exposure classes, and it is going to be related to the minimum cover size, considering carbonation and chloride damage, or also free-thaw, etc. So these exposure-resistant classes, the definition will be included in other standard, in the standard dealing with concrete, the EN 206. And it is expected, because still is under discussion in the corresponding technical committee 104, that there will be two ways to approach the definition. One is through prescriptive rules for mixed composition rules, especially for conventional well-known concrete mixes, or by other ways, which is the short-term performance test, in order to deal especially with new concrete compositions. So this is a crucial new that we need to take into consideration in the new content of the Eurocode 2. But the problem is that the definition, in order to be applied of these exposure-resistant classes, is not the responsibility of Eurocode 2, but is the responsibility of the standard on concrete EN 206. So throughout these definitions, we have the typical tables for minimum cover size. In these examples, is only for exposure classes by the attack of chlorides, but it is interesting to highlight that the ERC types are defined in the case of the chloride attack as a dimension of a diffusion coefficient in these units. And in the case that is not presented here in this slide of the carbonation, this is on the dimensions of the carbonate rate in millimeters divided by JR to square root. Well, this is a crucial new that we are interested to finish the knowledge on this approach that is not under the responsibility of Eurocode 2, but on the responsibility of the standard concrete on 2006. So I would like now to ask Jose Maria to continue his presentation now.
Okay, Jesus. Good evening. I'm going to talk about three issues. First one is the concrete compressive strength. I think previous one. The concrete compressive strength. The first thing is that with this revision leaves open door to bring concrete's allowing ages for the test higher than 28 days. Green concretes are produced replacing a portion of cement by binder like fire ashes, for example. These concretes develop the strength slowly, and it's necessary to test the specimens at a higher age. So this is why now TREF may be between 28 days and 91 days for this course. On the other hand, we have any unification of the design value of concrete compressive strength among the different behaviors of the structure. I mean, bending, shear, punching, etc. In the actual version, in each behavior, this design value is taken into account in a different way. We obtain, let's see, the compressive strength from control specimen. From control specimen, like I see. And we obtain FCK. We obtain FCK from the control specimen. After we convert this compressive strength into the undisturbed compressive strength of cylinder, that means in plain concrete, cylinders with plain concrete without reinforcement, and then that conversion is made by gamma C, which take into account not only the uncertainties of the material and geometry, etc., but also this coefficient of conversion. So FCK divided by gamma C is the undisturbed compressive strength of cylinder. Now we are going to do another conversion to to convert this resistance into the effective compressive strength in structural member, I mean with reinforcement. When there are reinforcement, we have a brittleness because the possible splitting of the concrete. So this coefficient eta CC is the conversion from undisturbed to disturbed to real concrete in our structure. The expression is there, the quotient between resistance of reference and the characteristic strength of the test, and then with that we unify this strength among all the behaviors. Logically, when we are, for example, in bending, there is a difference. In the actual version, this brittleness is taken into account in the bending, but now it's not necessary. So the formulation is easier because the strength, the limited strengths epsilon C2 and epsilon Cu are now constant, independent of the class of the concrete. Why? Because this brittleness has been taken into account by FCD. Another subject is related to partial factors for materials. Very important. The basic data assume the basic coefficient of table 4.3. That's the partial factor, the usual partial factors for the structures. Now we know exactly which are the conditions for this coefficient. We see that these coefficients correspond to deviation of tolerance class 1 to execution class 2 in EN 13670, the execution of concrete structures code, and also that correspond to some statistical data of the variables with the coefficient of variation and the bias factor. So, for example, for yield strength, we have the coefficient of variation, also for the depth, also for the model uncertainty. And with these values, we obtain the coefficient of table 4.3. That means that if our statistical values are different, as there are a procedure to calculate this coefficient, this gamma coefficient, we can modify this coefficient if, for example, our production of concrete has a coefficient of variation less than 0.10, as is supposed. In this expression, all is developed in the Annex A. We can see the different variables, the sensitivity factor, which usually is 0.8, the beta target, the reliability index, which usually is 3.8, and the coefficient of variation and the factor of bias of the resistance. With that, we can reformulate, recalculate this coefficient. We have a list also of different typical conditions, many of them related to existing structure. For example, the condition B refers if we measure some geometrical measure. If we measure the geometrical, for example, the depth, so we can reduce the coefficient. For example, you can see GAM S maybe 1.04 instead of 1.15. In the D condition, there is another typical situation of existing structures. If we use core test, then we must reformulate the coefficient, the partial coefficient of the concrete, and you may find the instructions to do that. A particular case which improve the results is, for example, the use of a design value of the effective depth instead of a nominal value. If we use this effective value by calculated by the difference between the nominal value and a deviation, which in reinforcing steel is 15 millimeters, then we can reduce the coefficient. For example, you can see the coefficient, the partial factors of the steel, we can reduce from 1.15 to 1.03. All that makes adaptable all the partial factors to each situation, and that reduces obviously the quantity of materials and goes in the direction of sustainability. Then finally, my third issue is the shear. First, I'd like to say that we have preferred in the European Subcommittee the physical models than the empiric models, and then in shear and punching we use two physical models, one for shear for structures without shear reinforcement, and the other for structures with shear reinforcement. Both are based on Model Code 2010, and the first one is here, correspond to the concrete critical crack theory, which is applied to obtain the expression. You see the expression of the shear stress resistance. You can see this fraction dg divided by this is the size effect, and you can see a partial factor difference, gamma v, which really is gamma c, is the partial factor of the concrete. What happens then? There has been a calibration of the formula of shear, and it has been obtained that it was possible to reduce the partial coefficient of the concrete for the shear and for the punching, and its new name is gamma v. With this value, the result is quite more accurate. The other situation is when there are shear reinforcement. Then we apply the model of compression field theory. That's to suppose that the web, there is a compression field in the concrete with a determined inclination, and based on that, we can obtain the formula for the shear reinforcement. Really, for the first equation gives the resistance due to a reinforcement rho w, and then in the last equation we can obtain the compression stress on the web, on the concrete, that we must verify that it is less than nu multiplied by FCD, which represents the effect of the transverse strain on the compression field. And I finished my part, so Jesus will go on.
Thank you, Jose Maria. Just to introduce a minor slot, just when preparing the three of us to today's presentation, it will perhaps clarify that behind the new version of Eurocode, that most of these news are introduced in the background document, there are a lot of new work, new tests, new calibration of tests for the sake of trying to get an easy of use and a better way to save and to reduce the amount of material needed for the maintaining the level of safety required. Moving to the next topic that was also covered in the previous Eurocode, and there are important or relevant changes. The topic now is punching. Punching has produced some concern in the past, and during the life of the present Eurocode, there was an amendment in order to reduce the maximum punching resistance, etc., because there are there have been some accidents, and there are some concerns at European level. So although this is a European webinar, for those who are based in Spain, this also is related to the situation in Spain, which produce even a bit more reduced situation than the one of the present Eurocode. So we have to verify the typical verification of the punching perimeter. In this case, it has been established at a distance of the 0.5 the effective depth of the different columns, and then of course we are also to be obliged to verify the external perimeters in order to define the extension of the reinforcement. So as in shear, we have the concrete critical crack theory, and we have a very similar expression for the resistance, the shear stress resistance, the shear strength of the concrete when there are not reinforcement, there are not punching reinforcement, where, well, as always, the ratio of reinforcement need to be to take into consideration at always the rate of reinforcement in both directions of the slab. So this is a very similar approach than the one that was presented by Jose Maria in concrete, in the shear. So then when there is a need of including reinforcement, well, we have a typical formula of addition of the resistance without reinforcement and the new participation on the resistance due to the new reinforcement. And we have here the definition of the different coefficients that I am not going to enter in detail, and the definition or the value of the shear reinforcement needed in order to resist the shear value. Perhaps I would like to highlight in this presentation that today we think that the reinforcement using this type of stats are going to become more familiar than in the past in different countries due to several facilities in order to fulfill the requirements of the shear reinforcement distribution, the maximum distance between the reinforcement, etc. So we believe that against the typical bent up bars or stirrups, perhaps the use of this type of stats will become more familiar. Well, a hot topic of concern at the European level has been the maximum punching resistance, placing as much punching reinforcement as needed. So there is a maximum value that we cannot overcome. So the maximum value is eta 6 times the resistance when there are not reinforcement. This eta 6 is different if we are using stats or links and stirrups. This is a critical discussion. There is an additional possibility to increase these values, taking into consideration the membrane effect. This membrane effect for new structures will be included in a note and is up to each country to be used or not, the possibility to increase the capacity of punching resistance due to this membrane effect. But it is clearly stated in the case of existing structures, but I repeat, in the case of new structures, it will be up to each country to apply or not this improvement due to the membrane effect. Because if not, this limitation will limit. We will limit the size of the column with regard to the effective depth of the slab in some designs. The last topic that was covered in the past, and there are new approaches, is the anchorage length. In the anchorage length, the first new is that the anchorage length will be equal to the lap length. This is a new approach. We from Spain, we have some concern about this approach, but well, in principle, although this will be something that at national level will be possible to be modified. In principle, this is the approach that will be included in the Eurocode. And when some conditions are fulfilled, the anchorage length and the lap length is sometimes that is here written with regard to the diameter, depending on the concrete strength, the concrete strength quality. So in the case of 25%, 25 megapascals for buildings, well, and a bar of 20 millimeters in diameter will be 50 times the diameter. So when we will not fulfill in a general way the conditions to use this table, there is a formula where you can approach and obtain in a more precise way the anchorage length and the lap length, taking into consideration not only the diameter but also the stresses in the steel, the quality of the concrete, a correction depending on the diameter, a correction depending on the diameter versus the cover size, etc. And there are more information that for the lack of time I am not going to present. There are new formulas in order to take into consideration the external, how to improve the length and to reduce the length of the anchorage due to external pressure. Just with this comment, we finish the main topics that today we were planning to deal with in this short webinar related to topics that were covered in the present Eurocode that are being modified. There are more, but for our view, these were the main ones. And now we are moving to the second part of the presentation. And in the second part of the presentation, we are going to present some of the news related to new scope of the Eurocode, number 2, that topics that were not covered at all in the previous Eurocode. So you have listed here the 6 topics that if we have time, we will try to cover: the assessment of existing structures, the strengthening, the use of non-prestressed glass and carbon reinforcement instead of steel reinforcement, the stainless steel reinforcement, the steel fiber reinforced concrete, and the recycled aggregates for concrete structures. So related to the assessment of existing structures, well, there is an annex dedicated to that, and it is defined the scope. There are additional rules to cover, for instance, materials and systems that were not defined in the present Eurocode. For instance, one typical example is the use of plain bars. The plain bars are not covered in the main text of the Eurocode, neither in the previous one and nor in the future one, but this annex will give information on how to deal with plain bars in the existing concrete structures. Some additional rules when the structure does not fulfill the rules of detailings, which is very typical, that are included in the new Eurocode in chapter 11 and 12. Additional rules not for anchorage for plain bars, and consideration, and this is an important topic, for deterioration of existing structures. Only consideration. So the main limitation of the new Eurocode is that there is not still a European agreement at the level of a standard in order to include a precise quantitative way to deal with deteriorate concrete structures affected by corrosion. There are several topics to be covered in this annex on existing structures. This is an example on how to deal with the characteristic compressive strength of the concrete coming from drilled cores, and depending on the conditions of this drilled cores, the position, the amount, etc. Well, we have a coefficient in order to obtain from the characteristic in situ compressive strength of the concrete cores the characteristic compressive strength to be used in the calculations. This is the example of the rules in order to deal with the anchorage length of the plain bars, which are not covered in the main test. It's a similar expression than the one for the typical bars, but in this case with modifications in order to take into consideration that they are not rivet bars, they are plain bars. In relation with the corrosion, although it is said that there are only general considerations, I would like to highlight that we are covering, there are some recommendations how to deal with the reduction of the concrete cross section and the steel cross section. So in relation with the concrete cross section, there is a recommendation that to consider the complete concrete section, but with a reduced value of the FCK when there are not a high level of corrosion. In this case, we can consider all the section, but with a reduced compressive concrete due to the presence of cracks. And when there are high corrosion values or important relevant cracks width higher than 1 millimeter, we need to consider the possibility of the spalling of the concrete and consequently to use the reduce of concrete section. In the case of steel, we need first to consider the reduced steel cross section, either in homogeneous corrosion or in concentrate pits. And then we also have to deal with some recommendations about the stress-strain relationship. If there are a low level of corrosion, and perhaps this is the last draft version that has been distributed, or homogeneous corrosion, we can consider that there are not relevant modifications in the stress-strain deformation. However, if we have high corrosion penetration depth or fittings, we need to consider some reduction in at least in the elongation at maximum stress, and also to consider some active stress at pits. But these are only general considerations. And this is, I believe, my last presentation on this part. And for the case of possibilities of premature failure of stirrups due to corrosion, stirrups are the thinner reinforcing, we need to consider in compressive bars the possibility of buckling, and in the shear behavior, the possibility of that a premature failure of one stirrup can allow the shear crack to be produced with a reduced strength in shear.
So for the first time, Eurocode 2 will include an informative annex, Annex J, that will deal with strengthening existing concrete structures with carbon fiber reinforced polymer laminates, known as CFRP. Adhesively bonded reinforcement will be like the umbrella for the two technologies that are actually for this type of strengthening, which are externally bonded reinforcement, which consists on glue a CFRP strip or a CF sheet or pre-impregnated laminate to the surface of the concrete element. Or the other technique will be near surface mounted reinforcement, which consists on performing a slot cut in the concrete cover and then embedded a CFRP strip or a CFRP bar. So for shear strengthening is required if the average shear stress is larger than the shear strength of the original reinforced concrete element. Then there are different configurations that are considered in the Eurocode. One of them is fully wrapping the section. The other one is a U-shaped configuration. Both of them can be discontinuous or continuous along the element, depending on the shape of the section. Also, these configurations are the same as for confinement of concrete columns. So different formulations have been included in the Eurocode in order to assess the total shear strength, including the contribution of this FRP. And these formulations are based on the existing German guidelines. In relation to flexural strengthening, it consists on bonding an FRP laminate to the tensile face of the beam in order to have an additional reinforcement. To design this type of structures, we can consider the laminate as an additional reinforcement, but with a linear elastic behavior. The only point is that in most of the existing research, it has been observed that this type of by bonding this type of laminate, we can reach brittle failure mode, which consists on the debonding of the laminate at the laminate end or initiated between cracks, which is called intermediate crack debonding. So during design, we should check that this type of failure is not going to occur. For this purpose, we need to check the end anchorage. We should check that the force transferred by the laminate to the concrete in between the laminate end and the first crack is properly transferred to the concrete. And also between each pair of cracks, we should check that the increment of tensile force between two subsequent cracks is properly transferred by bond to the concrete surface. By doing so, we are going to guarantee that this type of failure is not going to occur. In addition, there is another annex that also for the first time includes in Eurocode the FRP embedded reinforcement. There are different types of embedded reinforcement considered, the ones made with glass fiber, basalt fibers, or carbon fibers. And here in this table, that is in the background document, we can see the huge range of the different parameters, such as the modulus of elasticity and the characteristic short-term strength, for instance, for the different types of materials considered. This type of reinforcement is going to be used instead of the conventional steel reinforcement, or can be used instead of the conventional steel reinforcement, and is very useful, for instance, in aggressive environments, because it is not susceptible for corrosion, and it's linear elastic up to failure. The only point is that it has been observed that this type of reinforcement decreases its tensile strength over time. So for design, we should consider the long-term strength that can be obtained from the short-term strength by applying some parameters that depend on the temperature, on time, and also on the environmental conditions. And instead of applying this type of parameters suggested by the Eurocode, we can also perform long-term tests in order to have the long-term strength that is going to be used for the design with this type of reinforcement. And this type of reinforcement is only recommended for tensile reinforcement, not for compression. And Jesus, if you would like to continue.
Thank you, Eva. Well, the last part of the presentation will cover another 3 areas of topics that are also new in the present technical draft version that still is under final adjustments for the preparing the final document to be submitted to the CEN for formal vote of by all the countries. And one of the topics is it is considered also for the first time the stainless steel reinforcement for concrete structures. So it is defining the different types of stainless steel with regard to the pitting resistance equivalent. And then we also have, between other content, a new table for minimum cover size of this type of stainless steel bars when they are using in concrete in different environment conditions. So there is a reduced values with regard to when we are using the conventional river bars. This is one of the next top of the new topics. The second one, although in some national code we have been using in the past, but it is also new in the Eurocode, is the use of steel fiber reinforced concrete structures. It was agreed with some discussions that only steel fibers. There are some approaches and there are some movements to include other type of fibers, but at the end, in the present technical content of Eurocode to be submitted to votation for the different countries at the beginning of the next year, only steel fiber is included. So the steel fiber reinforced concrete is classified depending on the ductility that is measured in the tensile strength when a crack of 0.5 millimeters appears, or the value when the crack reaches the value of 2.5 millimeters. And in function of these values, we have different ductility classes with the value of the tensile strength at 0.5 crack width, and the values of these corresponding fiber concretes with different ductilities, the value at 2.5 of the crack width. And with these values, it is possible to introduce in the different calculations of this type of concrete. Well, one interesting topic, at least for my experience, is that there is going to be an approach to consider the fiber orientation. So this is in the use of a reinforced concrete with fibers. There are at least two concerns. One is if we have the amount of fiber required, and the second one, if the distribution and the orientation of this fiber is adequate. So this is considered in the design of the residual tensile strength with this first coefficient, K0, to consider different situations where the fiber orientation can affect the tensile strength. And there is another interesting topic on this annex. There are a lot of topics. One is, what is the minimum conventional reinforcement in flexion, in bending, when we are using fibers? So there is an approach in order to decide that we need to have a minimum conventional reinforcement to deal with the crack width bending moment, when in this crack width bending moment, it is considered the strengthening due to the content of fibers in the concrete. The last topic today to be covered before asking Maria to coordinate the questions and answers is related to the use of recycled aggregates in the concrete for concrete structures. This is also a topic that in some national codes had been included and considered in the past, but this is again new in the new Eurocode. So there are two types of recycled aggregates, A and B, that are defining depending on what these recycled aggregates are coming from. In the case of the A is a high quality aggregate, we have here a recommendations. In the case of B, this recommendation need to be reduced by 50%. And well, it is said that we have in the A recycled aggregate replacing of less than 20% of the total aggregate, we can maintain the conventional approach of the concrete without recycled material. In the case of an amount of between 20 and 40, there are some information in this annex on how the conventional values to be reduced. And finally, we have more than 40% of recycled amount of recycled material. We need to test and to verify the properties throughout testing. In the case of the pre-stressed concrete, the amount is reduced. So here you have my email address. Sorry that they put only my email address. I forgot to include Jose Maria and Eva, but throughout this email address, if you are interested in this presentation or in some of the topics related to the background document and to the test that we are discussing at European level, where the next final theoretical approach meeting will be at the end of June, you can ask me and we try to respond and to attend your request. Thank you very much. Maria?
Thank you very much, Jesus. I'm going to ask also Eva and Jose Maria to turn on their camera and microphone. Hello again for the round table. I want to remind all the attendees that they can ask questions right now in the chat group. It's the moment. And first of all, I'm going to start with the question I think everybody wants to know is when and how will this Eurocode 2 be available?
Well, this is a complicated question. As Jesus has said, the document is practically finished. The date of the formal vote will be December of this year. After that, there is another date, the date of availability, which will be October 2023. So in this moment, we will have the document in the official languages, in English, French, and German. Afterwards, it depends. It depends why? Because at this moment, each country must translate the document into his language, except those countries who speak French, German, or English, and they must elaborate the national annex. A Eurocode cannot be used if there are not a national annex. The national annex has two main contents. On the one hand, define the nationally determined parameters. These parameters, which are in the Eurocode, always there is a value of reference, but each country must say if he wants to adopt this value of reference or he wants to change. It's compulsory, so to define for each NDP, for each nationally determined parameter, if the value. That's first. And second, there is the NCCI, the non-contradictory complementary information that every country is possible to include in this document. This is alternative methods to some methods on Eurocode that, for example, are not compulsory. Information about the annexes, for example, and all that. So this national annex, each country, the national standardization body of each country must elaborate. There is a limit, the date of publication, which is September 2027. But if any country has the document, the translation, and the national annex before, so the Eurocode can be used. And there is a last date, is the date of withdrawal of the actual Eurocodes, for all Eurocodes, and that date is March 2028. So that is, it may be expected that we will have the document 2024, 2025, if at the national level, we elaborate the national analysis and declaration and so on.
Thank you, Jose Maria. Another question some of our attendees just wrote is if it's necessary an updated of EN 1504 to convert to new EC2. I don't know if someone can answer this question.
Is this standard the one related to repairs? I am not familiar with the number of the standard. In order, if it would be possible.
The number, I can repeat it again. It's EN 1504, and they are asking if it's necessary to update that in related to the EC2.
Well, I am not familiar. I know this standard. I am not familiar with them. One of the problems that we have in the standardization of structures, not only at European level but also at national ones, is that everything related to a structural performance, structural verification, is the role of the Eurocode. But there are other standards on materials, on execution, on repair, etc., that are complementary and are needed in order to combine. So, in principle, these other standards should not include requirements and rules for structural verification. This is the role of the Eurocode. And Eurocode is not covering those situations or those rules related to materials, to execution, to repair materials, to execution repair, etc. This is the role of the corresponding technical committee and the corresponding standards.
Yes, Jesus, this code is products and systems for the protection and repair of concrete structures.
Yes, I know.
Okay, thank you. Okay, I think we have time for a couple more questions. I want to ask something else. Is it possible to evaluate corroded concrete structures with this new Eurocode?
In principle, no. I mean, due to the fact, as I try to express, that there is still not a general agreement at the level of standardization between all the technical experts in the different countries. There is still no complete agreement in order to develop in a parallel way with, in comparison with the new structures, all the formulation, etc. However, this annex is really a good advance related to shear, related to punching, related to anchorage, related to plain bars. So there is a lot of information. However, in the specific topic of deterioration, I mean of deteriorate concrete structures, still we need to progress. And we need to, at international level, the scientific and technical community to progress in order not only to publish research papers, but also to agree on common approach in order to standard. So this is a clear help, a clear tool to facilitate the evaluation of existing structures, and including the corroded one. But your question is, can we completely evaluate following the Eurocode? Well, still we need to take into consideration other manuals, guidelines, etc., in order to complement what is today agreed in the Eurocode.
Thank you very much, Jesus. And I think we have time for one last question. I think this one goes for Eva. Does Eurocode 2 cover the pre-stressing FRP?
No, it's not going to cover FRP pre-stressing, because at the very beginning, when we started to work in the task group, when we were defining the scopus, we decided that this is an almost emerging technology that has some research background, but not enough applications to be included in a code. So right now there are some initiatives in order to develop guidelines related to this type of application, but not in the text of Eurocode.
Just for the sake of those who are familiar with, you know, Jose Maria make a comment when dealing with shear that the evolution of the standards on concrete, structural concrete is not only but mainly based in the work of the FIB and the model code. So today, a model code was published in 2010, but now it is almost finished, the model code 2020. So for those interested who are interested to contribute in the progress of the approach of how to deal with concrete structures, in this case covering both new and existing structures, this model code, that is not a code, is really a model for those who have the authority to produce code. This model code will have a high influence in the future revision of the Eurocode number 2 in the next years.
Okay, I don't know if Eva or Jose Maria want to add something else too. Okay. Thank you again for being a speaker, all three of you today, and thank you to all our attendees also. I just wanted to ask you if you have 1 minute to fill our survey. You can find it in the chat. And thank you very much, everyone, again, for attending. See you next time in our next webinar. Thank you.
Thank you very much.
Bye.